Hi everyone, so today we're going to be going over some basic angle properties. These are probably things that you've seen already in classes previous, but we're going to do a little bit of review. For those of you that have already seen these things, if you haven't seen them before, make sure you're paying extra close attention. We're going to go through and explain them and then do some examples. And you're going to have an attempt at the examples on your own before I explain them. So the first thing we're going to go over is parallel lines cut by a transversal. Here you can see we have a set of parallel lines. I'm going to mark them with the marks that mean that they're parallel, and this line crossing them is called a transversal line. So this results in a couple of different kinds of angles. So the first four types of angles we're going to talk about are all congruent angle pairs. And the first one is called corresponding angles. So if we take a look at our parallel lines cut by a transversal here, where can we find our corresponding angles? Those are going to be found right here. 5 and 1 is one example, angle 5 and angle 1. If we look at where this transversal is cutting these parallel lines, angle 5 and angle 1 are both at the same position, right? So here if we look at this parallel line where the transversal cuts it, 5 is on top of the line and to the left. 1 is also on top of this line and to the left. So they're corresponding. They're at the same point at both of these lines being cut by the transversal. So angle 1 is going to be congruent to angle 5. And then to name some more corresponding pairs here, we also have angle 2 and angle 6. We also have angle 3 and angle 7, here and here. Angle 3. This little symbol I'm writing means congruent to. Angle 3 is congruent to angle 7, and this mark right here means angle. And then finally, our last pair of corresponding angles here is going to be angle 4 and angle 8. So next up we have vertical angles. An example of a vertical angle here is going to be angle 3 and angle 2. They're kind of like across from each other. Here you can see how like 4 triangles are formed here. 1, 2, 3, 4 triangles, 4 angles really. If you think about the ones that are opposite from each other, across from this vertex, they're called vertical angles. So angle 2 and angle 3 are going to be an example of that. Then angle 1 and angle 4. If we come down here, angle 5 and angle 8. And then finally we have angle 7 and angle 6. Next up we have alternate interior angles. And when we say interior, that means inside of these two parallel lines. So any of these angles in here, 3, 4, 5, or 6, those are interior, inside those two parallel lines. Anything on the outside, so 1, 2, 7, and 8, those are exterior. So that's how you define interior and exterior in this case. So alternate interior angles are going to be on opposite sides of this transversal. So they're both inside the parallel lines here, but they're on opposite sides of the transversal. So angle 3 and angle 6 are going to be congruent to each other. And then also angle 4 and angle 5. Next up we have alternate exterior angles. So I'm going to squish this in at the bottom here. Alternate exterior angles. So just like the alternate interior angles, they're going to be on opposite sides of the transversal, but now we're outside of those parallel lines. So angle 1 and angle 8 are going to be an example of that. Angle 1 is congruent to angle 8, and then angle 2 is congruent to angle 7. And then finally, we're going to have another corresponding another type of angle pair, but it's not going to be congruent to each other. They're going to be supplementary. So it's something called supplementary angle pairs. Okay. And supplementary means that it sums to 180 degrees. The angles are going to sum to 180. So here, my supplementary angle pairs are going to be consecutive interior angles. Consecutive interior angles. So again, we're interior, so we're inside of these two parallel lines. But now instead of being alternate, so on opposite sides of the transversal, they're going to be consecutive, so on the same side of the transversal. So here, angle 4 plus angle 6 is going to sum to 180 degrees because they're supplementary. And angle 5 plus angle 3 is also going to sum to 180 degrees. So now take a second and attempt this example on your own. This example says, in the figure below, line R intersects parallel lines L and M. So here's my transversal, here's my parallel lines, L and M. And angle 1 is not congruent to angle 2. So we know it's not perpendicular. We have some different angles going on here. How many of the other angles shown are congruent to angle 8? So we have to look at angle 8 and we're trying to find which of these other angles are congruent. Well, we know from the definition of vertical angles right over here that the one directly across from it, the one kind of opposite to it, is going to be congruent. So angle 5 we know is congruent. We know that our corresponding angles, so the ones that fall in the same place where this transversal crosses, so angle 8 and angle 4, we know angle 8 and angle 4 are going to be congruent because they're corresponding. And then we also, if we take a look at our alternate interior angles, that one's not going to give us anything because this one's not interior. And then finally, let's check for our alternate exterior angles. Angle 8 and angle 1 here are going to be alternate exterior. So angle 1. So those are all the ones that I see that are going to be congruent to my angle 8 here. So I'm going to say B, 3. Moving on to our idea of angle bisectors. So an angle bisector is going to be a line or segment that divides an angle into two equal parts. So here I have my angle AOB, and it's divided by this line segment OC here. So we can say that angle AOC, which is created right here by the side of my angle and my angle bisector, my angle AOC is going to be congruent to my angle COB. Because this angle this angle bisector splits this whole angle in half. So these two angles that are created, right here and right here, those are going to be congruent to each other. So let's take a look over at this example. Give it a shot on your own first. In triangle ABC below, points B, D, and C are collinear. Segment AB is perpendicular to BC. So let's take a look at what this means so far. B, D, and C are collinear, so they're on the same line, as we can see by our picture here. My segment AB is perpendicular to BC, so that means there's a 90-degree angle right here. You can see that marked by this square. And segment AD bisects angle BAC. So my segment right here, AD, is bisecting this angle, BAC. If the measure of angle DCA is 60 degrees, so they tell us right now that this angle is going to be 60 degrees, what is the measure of angle ADB? So we're looking for this angle right here. Let's call this X. That's what we're looking for. So how are we going to go about finding X? Well, we know that in any triangle there's 180 degrees, and I have 60 degrees right here for this large triangle on the outside, And I also know this one's 90 degrees. So I can find this missing angle measure, this angle BAC, by adding together my 60 plus my 90, right? Because this one right here is 90 degrees. That's what that square means. That's going to get me 150 degrees. So these two angles added together are 150. So this one right here must be 30 degrees, this whole angle BAC, because this whole outside triangle, the angles all need to sum to 180. That's true for every single triangle. So this angle here is going to be 30 degrees, this whole angle. So then we need to keep in mind now, we're looking for our angle right here with the X on it, angle ADB. So we have to do the same thing again. We see that this angle is bisected. So we know that for this smaller triangle right here, this angle measure on the inside is going to be half of this whole angle measure because this whole angle has been bisected. So I'm going to redraw this triangle down here. And this is going to be triangle ABD. So this is going to be 15 because that's half of our total angle measure, 30. This is still 90 degrees, as is shown by that little square. And this is the one that we're looking for. So again, let's add up our two angles that we know. And that's going to get us 105. And we know that the difference between 180 and our 105 is going to give us this third angle because all of our angles have to sum to 180. So 180 minus my 105, that's going to get me 75 degrees. So that's going to be my answer. The measure of this angle here, ADB, 75 degrees. Answer D.